Section 4.3, Matrix Multiplication. In this section, we're going to learn two types of multiplication with matrices. The first type is to simply multiply a matrix by a scalar, or a constant. And the second is to multiply two matrices together. In scalar multiplication, which is the simpler of the two versions of multiplication, we're simply taking a matrix times a constant element. And if you look at my two examples that I have here, the one on the left, I am taking the matrix 1.2, -3, 4, -8, 10, -1, and I'm going to multiply that matrix times the constant 4. And according to this process, what I need to do is simply multiply each element of the matrix times that specific value. So when I do this, I'm going to start here by multiplying each thing times 4. Now, a lot of people will sort of relate this to the distributive property, although that's not technically what we're doing here. But I end up with a matrix that looks like this. 4 times 1.2 is going to be 4.8. 4 times -3 is going to give me -12. 4 times 4 is 16. -8 times 4 is -32. 4 times 10 is 40, and 4 times -1 is -4. And that would be my resulting matrix. Okay, so let's do another example here quickly. If this matrix is to get multiplied by -2, again, I take every element in the matrix times -2. And I have a tendency to do row by row by row, but you can do it columns too. So I could do that on this one. -2 times 0 is going to give me 0, and -2 times 2.4 is going to give me -4.8. -2 times -6 is +12, and then -2 times 1.3 is -2.6. -2 times 0.8 is going to be -1.6, and -2 times -1.2 is going to be +2.4. And there is my matrix after the scalar multiplication. Now, in the last section, we talked about solving matrix equations, and we're going to continue that in this section using our scalar multiplication. So in this problem, if I'm going to solve this equation, I have a couple of issues with scalar multiplication. And the first one that I need to deal with is this scalar multiplication right here with my +2. So I want to combine that with the matrix so that I have just a single matrix to work with. So if I'm going to do that, my equation is going to look like this. So I have the 4x, which I haven't done anything with yet. And I'm going to multiply that scalar multiplication so that I end up with just a single matrix here. So my scalar multiplication is going to end up with 6, 8, -4, and 2. And then it still equals the same matrix that I had previously, 10, 0, 4, and 2. Now, the next step, again, following the process of solving equations, I have a choice. I'm trying to solve for x, and they are either multiplying x by 4 or they're adding the matrix 6, 8, -4, 2. And in my process of solving equations, anytime I have to solve an equation, the next step would be to get rid of the addition in this problem. So I'm going to use the opposite operation. I'm going to use subtraction, and I'm going to go 6, 8, -4, 2, and I'm going to subtract that like we did in the last section, 6, 8, -4, 2. That results in 4x equals the matrix. Let's see, 10 minus 6 is going to be 4, 0 minus 8 is going to be -8, and 4 minus -4 is going to be +8, and 2 minus 2 is going to be 0. Now, the only thing that I would do a little differently here is that typically we, a lot of us will think of the next step to be divide by 4, but we haven't talked about anything to divide in matrices yet. So the alternative to dividing by 4 would be to actually multiply by the reciprocal 1/4. I know how to multiply matrices times a number, so I'm going to use multiplication instead of using, quote, division. Okay, by definition of division, multiplying by 1/4 is the same as dividing by 4. So x equals, and when I multiply that matrix by that constant, 1/4, 1/4 times 4 is 1. 1/4 times -8 is -2. 1/4 times 8 is +2. And 1/4 times 0 is 0. So my final answer is the matrix 1, -2, 2, and 0. Now, when you multiply two matrices together, it's a little bit trickier. You have a few more restrictions as far as what can be multiplied and what cannot. And the first rule is that you can only multiply matrices whose inside dimensions match. And what I mean by that is when you set them up in order of multiplication, okay, so how they're going to be multiplied, the inside two dimensions of the matrices have to match. So in other words, if I had a 2 by 3 matrix and I wanted to multiply that with a 3 by 2 matrix, I could do that because the two insides of my dimensions would match. However, if I tried to change the order of those and I wanted to take a 3 by 3 or a 3 by 2 times, let's say, a 3 by 2, okay, so I wanted to multiply those together, that could not be done because these two dimensions do not match. So we couldn't multiply a 3 by 2 times a 3 by 2. Secondly, the process of multiplication is a little different. Since the dimensions of the matrix could actually be different, it doesn't work to just multiply element times element and element times element. It's not going to work that way. So let's go down here to my example. First of all, let's determine if multiplying these two matrices is even possible. So what I want to do for that is I want to check the dimensions. And if you look at the dimensions of my matrix, this one happens to be a 2 by 2 matrix. And this one also happens to be a 2 by 2 matrix. So when I look at them in order, the two inside dimensions are 2 and 2, so they match. Now, the next step is to actually multiply these out. And it says we need to multiply all the elements of the rows in the first matrix by the columns in the second matrix. Add these together and make an element of the product. Okay, so you're going to have to follow carefully with me now, but in the first matrix, I'm using rows. Okay, so what I'm going to do is I'm going to start with row number 1, and I'm going to multiply those elements with column number 1. And this is why my inside dimensions have to match, because what I'm going to do for this calculation is I'm actually going to take these elements, I'm going to multiply them, and I'm going to add them. So I take the first element from row 1 and the first element from column 1, and I multiply them together. -1 times -3. Then I take the second element of row 1 and the second element of column 1, and I multiply those together. 0 times 5. I add them together, and I get my answer. So -1 times -3 and 0 times 5. So that's going to be 3 plus 0 is 3. So the very first element that's going to go in row 1, column 1 of my product is going to be the number 3. Okay, now I repeat that process. Okay, so now I'm going to go back. Whoops, don't want to do that. I'm going to repeat that process. And instead of doing row 1 and column 1, this time I'm actually going to use row 1 and column 2. So I'm going to switch columns, but I'm going to finish out row 1 first. So row 1, column 2 is going to look like this. So again, first element, -1 times +3 this time, plus the second elements, which will be 0 times 0. Okay, well, -1 times 3 is -3, and 0 are still 0. So this one's going to end up being a -3. So in row 1, column 2, in my product goes -3. Okay, so now I have finished up both of my rows, or both my row with both columns. Now I'm going to go back and I'm done with that row. So I'm going to start the process over, and I'm actually going to do, let me change colors, maybe this will be a little easier to follow, the second row now, and I start back over with my columns. So the second row, 3, -4, and I'm going to multiply that with -3, 5. So this one, to figure these elements, will be 3 times -3, plus the second elements are -4 times 5. So 3 and -3 would be -9, and -4 and 5 are -20. So I actually end up with a -29. And since that came from row 2, column 1, in my product matrix, I find row 2, column 1, and I'm going to put -29. Okay, let's finish this up with the last element, which is going to be the second row again, this time with the second column. So what I'm multiplying together are these two. So 3 and 3, 3 times 3, plus -4 times 0 this time. So 3 times 3 is 9, and -4 times 0 is 0, so I end up with a +9. So since that element came from row 2, column 2, I'm going to put a 9 in my row 2, column 2. So matrix multiplication, they have to have the inside dimensions that match, and they also have to have your rows times your columns. Okay, let me try one more example for you here so you can kind of get the idea of the process, and then we will do a little bit more practice in class. So let's look at this first example. If you'd like to try the other two when you're finished, that'd be great. But what I'm going to do here is take each row times each column. So row 1 times column 1, we'll start with that. 2 times 8 is going to give me 16, and 3 times 2 is 6. Add those together, 16 and 6, and I'm going to get 22. Okay, so then I come in here, I'm going to stick with row 1, and this time I'm going to go to column 2. So in this one, 2 times 0 is 0, and 3 times -5 is -15. So my second element is going to be -15. All right, so I've finished up everything with row 1, so now it's time to switch to row 2 and repeat the process with those columns. So I'm going to repeat this column. -1 times 8 is going to be -8, and 8 times 2 is 16. -8 and 16 are going to be 8. Okay, stay with row 2, go to column 2. -1 times 0 is 0, and 8 times -5 is -40. 0 plus -40 is -40. All right, last row. First column, 4 times 8 is 32, and 0 times 2 is 0, so that element is going to be 32. And last column here, 4 times 0 is 0, and 0 times -5 is 0, so 0 plus 0 is 0.